Welcome back to Applied Mathematics. This video is slope and graphing lines. Slope is a very important and incredibly useful tool in problem solving, but it's one of those ones that makes the most sense once you already know what you're doing. So let's start off with the mathematical definition. Let me get my head out of the way and let me sketch a quick graph of a linear equation. The equation doesn't really matter. The graph doesn't really matter, but we need a linear equation. We're going to find any 2 points on the graph. We're going to call the first point here, coordinates x1, y1, and the second point here has coordinates x2, y2. We're going to define the slope using the letter m as the difference in y. Sometimes you'll see that denoted using this triangle. It's the Greek letter delta, and it's read as change in. So change in y divided by change in x. Well, the change in y is the difference between the two y coordinates. y2 minus y1, the change in x is the difference between the two x coordinates. x2 minus x1. Which point you call which doesn't matter when you're calculating slope. You could do it either way, but you do have to make sure to stay consistent, right? x2, y2, the first coordinate that you use in the numerator and denominator has to come from one of the points, and x1, y1, the second coordinate you use in the numerator and denominator, both have to come from the other point. All right, so making sure that you keep which point is which straight is the one thing you have to pay attention to. So if I look at a particular example, again, I'm not writing the equation of a line. I'm just know that a linear equation has a graph that is a line. Let's have the line go in a different orientation this time. And let's say that this is the point. Actually, let's not use that point. Let's use this point. Let's say that's the point -2, -1. And this is the point 12, 7. There is exactly one line that goes through those 2 points, although there are many lines that have the same slope. The slope here, choose whichever point you want as x2, y2, but make sure that you stay consistent. I'm going to use this point. So the second y coordinate is 7, the second x coordinate is 12. I subtract, and then I have this point. I'll subtract the y coordinate of that point, -1. I'll subtract the x coordinate, -2. 7 minus -1. Why did I call that -1? As I graphed that, that is pretty clearly a positive one. But I like the number, so let's fix the picture to make it actually look like the point I said it was. All right, -2, -1 is more like there. 12, 7 is somewhere like there. All right, now I have the picture that I said I had in the first place. Anyway, 7 minus -1 is 8. 12 minus -2 is 14. 8 over 14 reduces and becomes 4 over 7. We generally leave slope as a fraction. Improper fractions never mix numbers. Decimals can work, but they're hard to interpret, so fractions is almost always the best way of dealing with it. All right, there is my slope. Now that we have a basic idea of how to calculate a slope, let's take a look at the example that we used previously of a ball rolling down a hill. And think about what the slope is actually going to calculate here. All right, so my change in y is change in height And my change in x is a change in time. And you might recognize this from a basic physical sciences course. If you take how far something has moved and divide by how long it takes to move there, you get the speed. Or more generally, the slope measures the rate of change. How fast is the height changing with respect to time? How much is the temperature changing with respect to the altitude that you are in as you're climbing a mountain? How much is the cost of the bologna you're buying at the deli changing with respect to the amount of bologna that's on the scale? Any kind of rate of change can be modeled as a linear equation and can be thought about using slope. There's a ton of application that we can get into here. We've already talked about rates and applications of rates. For the sake of time, I'm not going to get back into it again, but I wanted to mention that all of this stuff does tie together. Unfortunately, the pacing of this course means that I just give you the building blocks and you have to rely on a future course to see how everything ties together. Instead, I want to focus on how slope and graph relate to each other. It turns out that if you have a point, let's go ahead and take the point 2, 1 as our starting point, and you have a slope. Let's go ahead and take the slope 3/4. Those two pieces of information are everything that you need in order to graph a line. I'm going to do my best to show you what I mean, but this is one of the places where not actually being in front of you waving my arms around makes things challenging. All right, let's start off by plotting our point. 2, 1 is right there. Right, I'm just going to use the grid with every tick mark on the grid meaning one spot, because putting all of the numbering down is going to make it harder to see what I'm actually trying to convey here. My slope is 3/4. Slope is change in y divided by change in x. So if I change y by 3 and I change x by 4, that takes me to this point. And I know that this is going to be a point on the graph. And I can do it again. I can from here change y by 3, change x by 4, and get another point on my line. The next part is a little bit weird, but once you get used to it, it really will work for you. I can write 3 divided by 4, but thinking about properties of signed numbers, -3 divided by -4 is the same thing as +3 divided by +4. So I can just as easily go in the other direction. Change y by -3. Change x by -4 and get to this point, which is another point on the graph. And I can do that again and get this point. So you get all of these points just by knowing a starting point and knowing a slope. Play your game of connect the dots. Let's pretend that that line actually passes through all 5 of those points, and you have the graph. That is even more powerful than it probably seems at first glance, because we have a tool called slope-intercept form. If you happen to have a linear equation which is written in the form y equals mx plus b, it automatically tells you the slope and a point. Whenever you have an equation in this form, the coefficient on x is your slope. The constant term is the y-coordinate of the y-intercept. The x-coordinate of the y-intercept is always 0. The y-coordinate is this value b. Your slope, your point, are read directly off of the equation. You don't have to do any work whatsoever. So if I have the equation y equals negative 3 over 2x minus 1, I can just look at the equation and say that the slope is negative 3/2. I can say that the y-intercept is 0, negative 1. It's right there in the equation. The information is here for me. I just have to write it down. Once I have written it down, I can sketch out some coordinate axes. I can plot 0, negative 1. I can think about my slope. Right? I can either think about that as negative 3 over 2, which takes me to here. Do that again, negative 3 over 2. Or I can think about it, why did I do that? That's not what I wanted to do. Negative 3 over positive 2 brings me here. Negative 3 over positive 2 again brings me here. Or negative 3 over 2, or I'm sorry, negative 3/2 can be thought of as positive 3 over negative 2. So change y by positive 3, change x by negative 2. Do that again, takes me into the equation I just wrote down, and we have our graph of our line going in that direction. All right. There is a ton that I can do with slope. If I spent an entire semester just talking about slope, I could do it. I only have this video though, so that's all I'm going to try to do for this one. As always, thank you for joining me. I'll see you next time.